In the last section, we learned some basic integration techniques. Unfortunately, those do not always apply, so we have to do some substitution to make those basic rules apply to other types of integrals. And so we're going to use what's called U-Substitution, and here are some steps. But basically, what we're going to be doing is we're going to take mainly the most complicated part of the function and make that u, and then we've got to find that du. So our goal is to make it into the form of u du, maybe u to some power, so we can use the power rule, 1 over u du, so we could use the natural log rule, etc. Alright, so let's just kind of dive in and see how we do that. Right? This first one, we have these two functions being multiplied together. You might notice that this one has a squared. So that would be the more complicated function. Let's let u be the inside function. That's kind of this part. So let's let u be x cubed minus 2x, and then take the derivative. So du would be 3x squared minus 2 dx. Now this is where you kind of look and see if you can play a matching game. Alright, so I've got the integral. I let this be u, that's squared, and look at what I have left. Exactly what that is, which is du. Now I can integrate that using the power rule, which means we raise the exponent 1 and then we multiply by the reciprocal of that exponent. But don't forget to put that plus c. We're not done because the original problem was in terms of x and mine is in terms of u. So I've got to go one more step, which is here. I've got to replace u by g of x. So this is 1/3 what was u, which is x cubed minus 2x raised to the third power plus c. This takes a little bit of practice to kind of maybe recognize what you want u to equal to. Let's look at this next one. Alright, well certainly the denominator looks more complicated than the numerator. And remember, anything you have to a power, you usually want to let u equal to the thing without the power. Let me restate that. Take that with the power, but when you're letting u take away the power. So let's let u be this. Then du is 4x dx. Now let's see if we can match. Alright, 4x dx, all of that is du. On the bottom I have u, and I'm sorry I've kind of drawn over it. Let's see, that was to the third power. All the top, 4x dx, is du, and on the bottom that's u to the third power. Can I integrate that? Yes, because I can rewrite this as a negative exponent and then use the power rule. So add 1 to the exponent and multiply by the reciprocal of the new exponent. Then you want to make sure you go back and replace u with your function of x. So I have negative 1/2 times 2x squared plus 3 to the negative 2 power plus that unknown constant. Right? This next one, we have a square root. Obviously that's the more complicated part, so I'm going to let u be what's underneath the square root. Take the derivative, and then let's see what we've got. Right? If you notice, 3t squared dt is du. So all of this is du. Right? Inside here, that's u. The square root is the half power. And voila, can use that power rule again. So add 1 to the exponent, multiply by the reciprocal of that new exponent, and then replace u with that function of the original variable, which in this case is t. Next example. Again, both of these look pretty much the same, but the denominator at least is a binomial, so let's let that be u. The derivative is negative 5x to the 4th power dx. Now you might be thinking, well, I don't have that. That's true. I just have x to the 4th dx. I need just this part. Well, how can I get that part by itself? Well, what if I divide both sides by -5? So I have -1/5 du equals x to the 4th dx. Now let's make some substitutions. Okay, so again, what's x to the 4th dx? That's going to be -1/5 du. Anytime you have a constant, you can pull that out in front of the integral sign, divided by the denominator, which was just u. That is not the power rule, even though that is u to the -1 power. Remember, we can't use the power rule there. What this equals to, leave that constant, but this is the natural log of the absolute value of u plus that constant. Then go back and replace what was u, which is 1 minus x to the 5th plus c. Now we have an e. Well, we know how to integrate e to the x dx. That's just e to the x plus c. So let's see. We don't have x, we have a -2x. Sometimes we let u equal to an exponent, especially when you have an e, because that's your variable, it's in the exponent. So let's see how this goes. If u is -2x, then du is -2 dx. Well, so far I've got e to the u, but I just need a substitution for dx. So just like on the last example, I'm going to divide by -2. So dx is -1/2 du. So I'm going to replace this dx with the du, but I'm going to leave that constant on the outside. All right, now that rule matches this rule. So I have -1/2 e to the u plus c, which is going to be -1/2 e. My u is -2x. So when you're dealing with the e function, 99% of the time you're going to let u equal to that exponent. Here we come again. Well, not quite the same exponent. We have a product. But again, anytime you see an e, the first thing you should try is let u equal to that exponent. Let's take the derivative. And then let's see what we have. I'm going to write that larger. I have x e to the -x² dx. All right, so I know this is u. The question is do I have x dx? That's what I need to solve for. So dividing by -2, just like in the previous examples, I can now make that substitution that I have e to the u. X dx is -1/2 du. Just like the last example, I integrate that, but I don't get the same answer because my u is not the same. It was -x². Well, now I've got some e's on the top and the bottom. Well, the bottom is a little bit more complicated because it has that 1, so let's go for that. Let's let u be that denominator. I think if we let u just equal to x, that's not going to help. All right, let's take the derivative. So what do I have? On the bottom, I have u, and on the top, I have e to the x dx, which is du. So again, that's the natural log of the absolute value of u plus c. But what is u? 1 plus e to the x. Some more e's. This time we have a different type of exponent. Anytime the exponent on the e is something other than x, again, I'm going to let u equal to that exponent. I'm going to change that to the half power. Take the derivative. Let me rewrite that. That's 1/2 over times 1 over the square root of x dx. Sometimes it helps to kind of separate that. Right? So on top, I believe I would have an e to the u. It's this other part, dx, divided by the square root of x. That's close. So I just need to multiply both sides by 2 here. So I have dx divided by the square root of x. So my integral is e to the u, and then all of this part, dx over the square root of x, is 2u. Let's see, somewhere along the line I've made a mistake, because when I took the derivative, that should have been du. There you go. That would make sense. So I have 2 du. So I have 2e to the u plus c, 2e to the square root of x plus c. Alright, so just to review, when I took the derivative, I should have had that du there. More e's. This time, hopefully, we're going to go back to what we kind of started out with. We have a binomial raised to a power. So let's let the u be that binomial. Take the derivative, alright, so we e to the 2x times the derivative of the power, and the derivative of 1 is 0, so that would be dx. Alright, let's see if we can kind of play the matching game. I have e to the 2x dx. I have just this part in my problem, so dividing by 2. So let's see if we can make that substitution. Here I have u cubed, and this part, which is here, is going to be 1/2 du. So we raise the exponent to 1 more, multiply by the reciprocal of that exponent, put our constant, and then replace u with whatever it was to begin with, which in this case was e to the 2x plus 1. I hope you're seeing the pattern. It does take some practice, but it's not real hard. Okay, now these are 3 different problems, all with the natural log. Alright, we do not have a rule to integrate the natural log. We have this rule, which gives us the natural log, but we don't have it the other way around. So we've got to make some type of substitution. I'm going to let u equal to the natural log of 5x. The derivative of the natural log of 5x, as you may recall, this goes on the bottom, and the derivative of that goes on the top. Let's just simplify that. Okay, so as I'm looking at this problem, the integral of the natural log of 5x over x dx, what do I have? Well, dx over x is du, that's that part, and this part is u. So I have u times du. I can use the power rule, and then I can make my substitution. There you go. Okay, let's see if this works again. Again, let's let u equal to that natural log of x. du is 1 over x dx. So as I go back to my problem, I have 1 over x natural log of x dx. Let's play that matching game. This and this is du. So I have du, but I have the natural log of x, which is in the denominator. That's u. Now that looks weird. How do you integrate that? Right up there. So this is going to be the natural log of u plus c. What was u? The natural log of x. So we have the natural log of the natural log, which is kind of bizarro. So I'm going to leave that one for your thought, but again, anytime you have the natural log in there, let that be u. On the last problem, or number 21 of your homework, I think it is this problem. They may have changed some numbers. And so got a number of TV viewers has been increasing at this rate, and they really should have had like an f of t or something like that. T equals 1 is the year 2006. This is kind of like an initial value problem that we had studied before. So what we're going to do is we're going to integrate the given function, and then you'll get a function plus that constant. And then this is your initial value. So when x is 1, y is going to be 9 times 5/2 to the 2/3. So if you make that substitution, you're going to find out what c is. And then once you do that, you'll have your function, and then you can, if it says for 2011, whatever year that corresponds to. So let's see, if t is 1 for 2006, 2 would be 07, 3 would be 08, 4 would be 9, 5 would be 10. So let t equal to 6 would be for 2011. But again, it's that initial value problem. You're integrating. But to sum it up, what you've got to do is you've got to take integration problems and make them fit those basic rules we learned in the previous section. And so we talk about U-Substitution. Sometimes it's the inside function. If it's an e to some weird power, you're going to let that be u. But the key thing is make sure you have that du. If you have an extra constant, as you saw, that's okay. Those constants can go outside the integrand.